Hey guys, so today's lesson is about optimal volume and surface area, and it's really similar to what we were looking at in terms of optimal perimeter and area. It's just that now we're in the 3D sense, and just like it was a square for area and perimeter, this time we're just going to make that square a 3D and it becomes a cube. So among all rectangular prisms with a given surface area, a cube has the maximum value. So we're looking at cubes. And among all rectangular prisms with a given volume, it is the cube that has the minimum surface area. And I've put some examples here. You can see this one's 3.2 by 2.5 by 1. And its volume is 8, but its surface area is 27.4. But with the cube, it has a surface area of 24. And even this is a different example as a surface area of 24, but notice that the volume is much smaller. So it is this one, this cube, that has the smallest surface area and the biggest volume. I'm not going to have us do an investigation like we did last time because we kind of did some of that investigating in the last lesson when we looked at area and perimeter. But I will go right to the examples. So we're going to optimize a rectangular prism. Rosa constructs a rectangular prism using 384 square inches of cardboard. So that is our surface area. Surface area is 384 inches squared. It has the greatest volume possible. What are the dimensions of the prism? So greatest volume. Okay, so because it's the greatest volume, I automatically am going to think cube because that's what we saw in the first part of the lesson. So what I'm going to do is I'm going to figure out what does my length, width, and height have to be. Now, if we're thinking about surface area, all the surfaces on the cube are exactly the same. So because we know this in a cube, all the sides are exactly the same. I have 6 sides that are length times width, and that is also that will equal our surface area, which we know is 384 inches squared. So what I'm going to do is I'm going to solve for our length and our width, which I know are the same because we're dealing with a cube which has square sides. So I'm actually going to change this to 6L times L, which is L squared, equal to 384. And I'm going to solve for L. So we will divide by 6, both sides. So it'll cancel on this side. We'll get L squared equals 384 divided by 6, which is 64. And then if we take the square root, we can easily find what L is. And we get L to be 8. So if I'm looking at this one, this particular example, her rectangular prism for Rosa has dimensions 8 inches by 8 inches by 8 inches, and it will have the maximum volume. If you want to know what that volume was, we would just calculate it. Volume is length times width times height. So 8 times 8 times 8, which is 512 inches cubed as our maximum volume. It didn't ask you for that in this question, but that's what you would do if you had to actually find that maximum volume. Let's look at B. Liam constructs a rectangular prism with a volume. So this time they're giving us the volume of 1,331 meters cubed. It has the least surface area possible. What are the dimensions of the prism? And then what is its surface area. So we're going to do the same thing, but we're going to go backwards. This time we have the volume. So this is B, and the volume we know is 1331 meters cubed. Now, again, because it's a rectangular prism, we're going to go straight to a cube, which means the length, the width, and the height are all the same. So I'm going to set this equal to length times length times length, similar to what we did in the last one. 1331 is L cubed. And then we're just going to solve for it. So I'm just going to take the cubed root of 1331 to find L. So now careful with your calculators. Some of them, they do things differently. Sometimes you have to do the cubed root first and then the number. Sometimes you have to do the number and then the cubed root. So make sure you know how to do this on your calculator. And some calculators have that, actually have the cube root button. But I got 11. So make sure that you can get 11 as well. So now I know length is 11, width is 11. The width is 11 and the height is 11, and they're all meters. And then it wants the surface area, so we'll figure out the surface area, which is 6 sides that are all like length times length. They're all 11 by 11. And I'll calculate it. 11 times 11 is 121, and then we have 6 sides of that. Gives us a surface area of 726 meters squared. Okay, let's move on to the next page and we'll talk a little bit about cylinders and their maximums. Okay, so on the other page, Nathan is designing a can with volume 350 milliliters. What is the minimum surface area of the can? Determine the dimensions of a can with the minimum surface area. Now, when we have minimum surface area, if we did a bunch of investigations and stuff, we would find that in order to have minimum surface area or maximum volume, the height is 2 times the radius. So for example, if we had a height of 2 centimeters, then our radius would end up being 2 times 1, because our radius is, so our radius would then be 1. So then you get 2 times 1 is 2, but it also equals the height, which is 2. So we kind of got to work with that. You could also then say that the height is equal the diameter, because that works as well. So let's go to our example. We have 350 milliliters. Now I told you that 1 milliliter was 1 centimeter cubed. So milliliters aren't as easy to work with when we're dealing with surface area. So we'll just change this to 350 centimeters cubed. So we're going to take this, we're going to sub it for volume, because we know that that is 350 centimeters cubed. And we're going to solve for the radius in order to find out what the radius has to be and then what the height has to be. So we know that the volume of a cylinder is pi r squared times h. From over here, h is equal to 2r, so I'm going to sub that in. So r cubed times 2r. Sorry, that's r squared. R squared times 2r, which is 2 pi r cubed, is 350. We're going to solve for r cubed, so we're going to divide the 350 by 2 pi. So we're going to move that 2 pi out of that side. 350 divided by 2 times pi is 55.7, and that's r cubed. So I'm going to take the cubed root of that to find out what r is. And I get 3.8. So r equals 3.8. In this case, it's centimeters. And then we can go back to here and find out what our h is, because h is 2 times r. So 2 times 3.8. Our height is 7.6. So determine the dimensions of the can with minimum surface area. So min surface area. Surface area results in a can that has radius equal to 3.8 centimeters and a height that is 7.6 centimeters. Okay, that's it for today, guys. Make sure you do the practice questions for this. It makes more sense when you get a little bit more practice in with it. And good luck.